Okay friends, today we discuss about the secondary concepts questions asked in 24th day, that means in the first session of JEE mains examination. Okay, what is the first question? Consider a parallel plate capacitor of area A of each plate and separation D between the plates. If E is the electric field and epsilon naught is the permittivity of free space between the plates, then potential energy stored in the capacitor is, to see, this is a parallel plate capacitor. Okay, A be the area, okay, D is the distance between these two plates. Okay, you know, this plate becomes what? Positive, this plate becomes what? Negative. So some potential difference existing between these two plates. Okay, the air in between the space of these two parallel plates, its permittivity equal to what? Epsilon naught. You know, due to this positive charge, electric field towards the negative direction, due to negative charge, the electric field towards this direction is equal to what? E2. So both are in same direction, so net electric field E net is equal to what? E1 plus E2, E1 plus E2, you know very well. Okay, so what generally parallel plate capacitor says, it is stored the energy in the form of what? Electric field. So for that it may do some work, that means the work done, what is that? The work done to store charge Q, the work done to store the charge Q, okay, at some potential drop V is or will be stored in the form of what? Potential energy. Therefore work done is equal to what? Half C V square, which is equal to what? Energy stored in capacitor plates. Okay, you know, this capacitance C is equal to what? Capacitance of parallel plate capacitor, which is equal to what? Epsilon naught A by D. That means the capacitance of a parallel plate capacitor is depends on cross section area of the plates, separation between two parallel plates. Okay, and V is equal to what? E into D. Potential equal to what? Electric field into distance. Okay, therefore energy stored U is equal to half into C is equal to what? Epsilon naught A by D into V square means what? E square into D square. 1 D is cancelled. That implies energy stored U is equal to 1 by 2 epsilon naught A into E square into D. Okay, this is the answer for this question. That's it. Okay, right. To the second question, what is the relative decrease in focal length of a lens for an increase in optical power by 0.1 diopter from 2.5 diopter? Okay, what is the relative decrease in focal length? But what is given? Increase in optical power. So what is given? Initial power. Say what? This is what? 0.1 is the increase in optical power. What is that? Increase in optical power. That means delta P is given. That means P2 minus P1, final power minus initial power, is equal to what? 0.1 diopter, from which 2.5, that means 2.5 is the initial power. That means given initial power, say called P1, is equal to what? 2.5 diopter, isn't it? So increase in optical power equal to what? P2 minus P1 is equal to 0.1 diopter. That implies final power P2 is equal to what? 0.1 plus P1. That implies P2 is equal to 0.1 plus 2.5 equal to what? 2.6 diopter. This is the power. Okay, but what is asking, what is the relative decrease in focal length? We know that okay, what is that? Power of a lens, power is inversely proportional to focal length. That implies focal length f1 is equal to what? 1 by p1, which is equal to what? P1 how much? 2.5, which is equal to what? 10 by 25, 5 2 ja 5 5 ja. This is the 1 by f1 equal to what? 2 by 5 meter. Okay. Similarly, that implies f2 final focal length, f2 is equal to what? 1 by p2, 1 by p2 is equal to what? 2.6. that means what? 10 by 26, 2 5 ja 213, 5 by 13. So, what is asking? What is the relative decrease in focal length? Therefore, relative decrease in focal length, relative decrease in focal length is equal to what is that? 1 by f2, 1 by f1 compared to initial 1 by f1 minus 1 by f2 by 1 by f1, isn't it? Why? Because relative decrease in focal length in terms of this one, what I say? P2 minus, that means P1 minus P2 by P1 compared to initial one, isn't it? So, in terms of focal length, 1 P is equal to 1 by then 1 by F, how much you get? F1 is equal to 1 by P1, F1 is equal to 2 by 5. That means what? This is equal to what? F1 minus F2 by F1 in terms of relative focal length. So, F1 is equal to what? 2 by 5 minus F2 is equal to what? 5 by 13 by F1 equal to 2 by 5. So, it may take LCM 13 into 5, 26, 5 5 is 25 by 2 by 5. So, 1 by 13 into 5 into, when it go to numerator, 5 by 2, this 5 is cancelled. That means what? 1 by 26. 1 by 26 means what? 0.04. That's it. It having no any units because it is related to focal length. Okay, right. The third question. During the transition of electron from state A to state C of a Bohr atom, the wavelength of emitted radiation is 2000 angstrom and it becomes 6000 angstrom when the electron jumps from state B to state C. The wavelength of the radiation emitted during the transition of electron from A to state B is, this is asking to see, according to Bohr's postulates, when electron is jumped from higher energy state to lower energy states, what happened? The energy is emitted in the form of a radiation. Okay. For example, see, there are three states. What happened during the transition of electron from state A? That means this upper state is A, lower state is B, and bottom is C, called C. When electron is jumped from, during the transition of electron from state A to state C, so the difference in energy, what is that? EA minus EC. Okay, EA minus EC is equal to what? H nu, according to quantum theory. Difference in energy equal to what? Photon energy equal to E is equal to H nu. But in wavelength is given, so it may write Hc by lambda. Why? Because nu is equal to what? C by lambda. Therefore, EA minus EC, that means difference in energy between state A to state C. According to the given question, the transition takes place from A to state C. So, equal to what? Hc by lambda AC. What is given? The wavelength of emitted radiation equal to 2000 angstrom. That means Hc by 2000 angstrom. This is equation 1. Next, what happened? And it becomes 6000 when electron jump from state B to state C. Now, what happened? Electron is jump from state B to state C. So the difference energy, that means what, EB minus EC is equal to what, HC by lambda BC is equal to what, HC by its wavelength is what, 6000 angstrom. This is the equation 2. What is asking, when electron jump from state B to state C, okay, then the electron wavelength of the radiation emitted from transition of A to B is, now you want to calculate A to B is equal to how much, what is the emitted radiation frequency, wavelength, emitted radiation wavelength. So it may obtain from EA minus EC, that means equation 1 is subtract 2, that implies EA minus EC minus EB, what is that, minus EC, which is equal to what, EA minus EC minus EB plus EC, isn't it? So minus EC plus EC cancel, but you know EA minus EC is equal to what, EA minus EC, what is that, HC by 2000 minus EB minus EC, what is that, HC by 6000, you know, EA minus EB, that is finally get EM, therefore EA minus EB, this is required while electron is jumped from state A to state B, is equal to what, is equal to HC by lambda AB, isn't it? The energy, difference in energy equal to what, HC by lambda AB, which is equal to what, HC by 2000 minus HC by 6000, on both sides HC is cancelled, that implies 1 by wavelength of radiation emitted from A to B while electron jump from state A to state B is equal to 1 by 2000 minus 1 by 6000. So LCM equal to what, 6000, okay, 3 minus 1 equal to what, 2 by 6000 equal to what, 1 by 3000, that implies wavelength of emitted radiation when electron is jumped from A to B, whose wavelength AB, wavelength lambda equal to what, 3000 angstrom, 3000 angstrom. So this is the answer for this question, okay, right. The fourth question, consider following statements, okay, actually this is the conceptual basis question. First option, the junction area of solar cell is made very narrow compared to photodiode. You know, the junction area of a solar cell, what is a solar cell? Solar cell is converted, okay, light energy into electrical energy, isn't it? So it is not depending on junction, it is made up of completely same kind of material, okay. Similarly in photodiode is also a kind of electrical device, actually it convert, okay, photo means light, it means light is converted into electrical energy, light is converted into electrical energy, so it is not correct, actually it is wrong, okay. Next, solar cells are not connected with any external bias, yes it is correct, it is a conceptual, but the solar cells are not connected with any external bias. If they are connected in external bias, there is no use, isn't it? So it may be correct. Next, LED is made up of lightly doped PN junction diode, LED light emitting diode, it is not, okay, made, okay, by two different kind of semiconductors, so it is wrong, okay. LEDs are made up of same, either silicon or germanium, whatever may be it, only one kind of semiconductor is used while making LEDs, not is a PN junction. Next, increase in forward current result in continuous increase in LED light instantly, already I told you, increase in forward current result continuous increase in LED, so it is also not correct, it is wrong. Why? Because increase in forward, that means the intensity of LED is depends on incident radiation only, but not increase in forward current, okay, right. Next, E, option E is LEDs have to be connected in forward bias for emission of light, yes it is correct, okay, right. So option B and E only correct in this question, okay, right. Right, the fifth question, the Young's double slit interference experiment is performed using light consisting of 480 nanometer and 600 nanometer wavelengths to form interference pattern, okay, right. the least number of bright fringes of 480 nanometer light that are required for the first coincidence with the bright fringes formed by the 600 nanometer light is. This is the question. Okay. You know, in Young's double slit experiment, due to interference of two light waves, what kind of light waves? Coherent light sources, coherent waves or interfere. There is a pattern, there is an alternative bright and dark fringes are so formed. This is called interference. Okay. So, what is here? This experiment is performed with using of 480 nanometer wavelength light and 600 nanometer emitted wavelength light. Okay. So, to find the what happened, the least number of bright fringes of 480 nanometer light that are required for the first coincidence with the bright fringes formed by the 600 nanometer is. Okay. So, what is that? To find least number of bright fringes of 480 nanometer, what is that? To find least number of bright fringes with 480 nanometer. What is that? To find least number of bright fringes with 480 nanometer light. What is that? That coincidence. What is that? That coincidence. What is that? That coincidence with a bright fringes of bright fringes of what is that? 600 nanometer. What is that? 600 nanometer. Okay. 600 nanometer light, 600 nanometer wavelength emitted light source. Okay. So, we want to calculate which one is coincidence. Okay. With least coincidence of multiple LCM you should supposed to be calculated. So, here what is given? Lambda 1 is equal to 480 nanometer and lambda 2 is equal to what? 600 nanometer. You know what is the fringe width? What is the fringe width? What is the formula of fringe width? Beta is equal to lambda d by d. What is that? Lambda d by d. Here for using 480, nth number, okay, is supposed to be coincidence. Is supposed to be coincidence. Okay, which is coincidence with nth number of bright fringe while using 600 nanometer wavelength light. Okay, both are same. That means what? Here to see, here B1, this is B2, here this is lambda 1, this is lambda 2, here d is the distance between slits and the screen, and d small d is the distance between slit width in interference pattern of a Young's double slit experiment. So, what happened if B1 is equal to what? B2. So, what happened? That implies lambda 1 d by d into n is equal to lambda 2 d by d into m. This lambda d by d is cancelled. That implies lambda 1 n is equal to lambda 2 into what? M. Okay, here to see, you want to calculate LCM. That means what I say, 480 is equal to, how to write its factors, 2 power 5 into 3 into 5 power 2. Generally you can know very well while calculating factors of it. 480 equal to 2 power 5, 3 into 5 power 2. Similarly, sorry, 5, 3, only 5, yes, right. Next 600. While you find the LCM of factorization of 600, which is you get 2 cube 3 into 5 square. Therefore, LCM, what is the LCM value? 2 power 5 into 3 into 5 square, isn't it? 2 power 5 into 3 into 5 square. You get 2400. You get what? 2000. Therefore, n is equal to 2400 by 480, isn't it? M is equal to 2400 by 600. Okay, so 2 1 2, it means 2 20 21 20, that means 1 0 is cancelled, then you get its value is equal to 5 approximately. Yes, 5. So this is the answer. Why? Because you want to calculate, okay, what is it, the least number of bright fringes of 48 nanometer, right, that are required for the first coincidence with the bright fringes formed by the 600 nanometer. So he is asking only n value. So here n you get n is equal to what, 5. Okay, so the answer is what, 5. That's it. The sixth question, a thin plano convex lens made of glass of refractive index 1.5 is immersed in a liquid of refractive index 1.2. When the plane side of the lens is silver coated for complete reflection, the lens immersed in the liquid behaves like a concave mirror of focal length 0.2 meter. The radius of curvature of the curved surface of the lens is, this is the question. You know, a thin plano convex lens, suppose to see this is a thin plano convex lens, one side is plane, another side is convex. So this is a plano convex lens, okay, of refractive index mu, okay, of glass is equal to what, 1.5, immersed in a liquid of refractive. Suppose this is the, okay, thin plano convex lens immersed in a liquid of refractive index, that means refractive index of water is equal to what, 1.2, this is 1.2. okay. Moreover, what happens when the plane side of the lens is silver coated, it is complete silver coated for complete reflection. So now it is act as a concave mirror. What is it? Concave mirror. Okay, a focal length what, 0.2, focal length of concave mirror what, 0.2 meter. The radius of curvature of the curved surface, then what is the radius of curvature R of this curved surface? R is equal to what? This is supposed to be asked. Okay, you know one thing, refractive index of water, in this one what happened, image is formed. So which is what, refractive index of water by image where is formed in the water. So by V, distance V is equal to refractive index of water minus refractive index of glass by what is that, R. Okay, radius of curvature mu W minus mu G by R. Okay, so you get which is equal to what is that, 1.5 by V is equal to 1.5, sorry, mu G minus mu W, 1.5 minus 1.2 by R. Therefore, 1.5 by V is equal to 0.3 by R, 0.3 by R. That implies V is equal to what, 5R, 3 1 ja, 3 5 ja, 5R equal to V. Okay, V is equal to what, 5R. Later what happened, for complete reflection, what is the formula of 1.2 by F minus 1.5 by 5R U minus V is equal to 1.2 minus 1.5 by minus R. So what you get, 1.2 by F minus 0.3 by R, 5 1 ja 5, 0.3 times is equal to what, minus 0.3 by minus R, minus minus cancel, that implies 1.2 by F is equal to 2 into 0.3 by R, isn't it? That implies F is equal to what, 2R, that implies R is equal to what, 0.1. So this is answer for this question. Okay, right. The seventh question, a plano convex lens having radius of curvature of first surface 2 cm exhibits focal length of f1 in air. Another plano convex lens with the first surface of radius of curvature 3 cm has focal length of f2 when it is immersed in a liquid of refractive index 1.2. Okay, if both the lenses are made up of same glass of refractive index 1.5, the ratio of f1 and f2 is, this is a question. To see here, there are two plano convex lenses. Suppose this is the first plano convex lens. Okay, its one side's radius of curvature is r1 equal to r. Second radius of curvature r2 is equal to what? Infinity. Why? Because it is a plane. Okay, first it is kept in a air. Moreover, this is the planar convex lens made up of, if both the lenses are made up of same class of refractive index mu is equal to what? 1.5. Next, another planar convex lens, okay, its radius of curvature r1 is equal to what is given? Is it given? Yes. Another planar convex lens with the first surface of radius of curvature is what? 3 centimeter. R1 is equal to 3 centimeter. This is R2 is equal to what? Infinity. Here R1 is also given. What is that? A planar convex lens of radius of curvature of first surface is 2 centimeter. What is that? 2 centimeter. Okay, both are made up of same glass of refractive index equal to 1.5. But this is kept inside a water. Okay, of refractive index is equal to what? 1.2. Okay, so what is the focal length ratio? So to see what is the focal length of any lens, okay, kept in air by using lens maker's formula, 1 by f1 is equal to mu minus 1 into 1 by r1 minus 1 by r2. Here 1 by f1 is equal to what is the refractive index of this glass? 1.5 minus 1 into 1 by 2 minus 0. Why? Because 1 by infinity equal to what? 0. Therefore, you get 1 by f1 is equal to what? 0.5 into 1 by 2. Okay, that implies you get f1 is equal to 4, isn't it? 1 by f1, what is it? 1 by f1 is equal to 0.25. What is that? 0.25. That implies f1 is equal to what? 4, isn't it? f1 is equal to what? 4. Is it correct? 25 by 100 means 1 by 4. Yes, f1 equal to what? f1. Next, this is the second lens of refractive index. What is that? Same 1.5 is kept inside a water of refractive index 1.2. So its focal length 1 by f2 is equal to 1.5 by 1.2 minus 1 into 1 by 3 minus 0. Why? Because 1 by r1 is equal to r1 equal to 3, r2 is equal to what? 0. Okay, so you get 1 by f2 is equal to 0.3 by 1.2 into 1 by 3. Okay, that implies 1 by f2 is equal to when you multiplied here 0.1 time, then 0.1 by 1.2, isn't it? That implies f2 is equal to 1.2 by 0.1, that means 12 centimeter. Therefore, f1 by f2, he is asking ratio. f1 is equal to what? 4, f2 is equal to what? 12, that means what? 1 by 3. So the ratio of, okay, focal length equal to what? 1 is to 3, that's it. Right, the 8th question. A parallel plate capacitor was made of 2 rectangular plates, each with a length of L is equal to 3 centimeter and breadth B is equal to 1 centimeter. The distance between the plates is 3 micrometer. Out of the following, which are the ways to increase the capacitance by a factor of 10? Okay, so first of all, you can find out what is the capacitance of this given parallel plate capacitor made up of 2 rectangular metal plates of length 3 centimeter and breadth 1 centimeter and the separation of 3 micrometer. To see, this is a rectangular metal plates, these two are the rectangular metal plates. Okay, by using, okay, you can made a parallel plate capacitor of area. What is the area of the metal plate? It does not given directly. What is that? Length is given. What is that? 3 centimeter. Breadth B is equal to what? 1 centimeter, and the separation distance between them, okay, D is equal to what? 3 micrometer. That implies capacitance of a parallel plate capacitor. What is that? C is equal to epsilon naught A by D. Okay, so you can write epsilon naught into A. Area is equal to what? Length into breadth by distance. Therefore, C is equal to epsilon naught into 1 length. Length is equal to what? 33. That means what? 3 into 10 power minus 2 meter into breadth is equal to what? 1 into 10 power minus 2 meter by, okay, D is equal to what? Distance. The distance of separation of 2 equal to what? 3 micrometer. 3 into 10 power, what is that? Minus 6 micro. Okay, minus 6 meter. So this 3 is cancelled, then you get epsilon naught, isn't it? Okay, so epsilon naught units is the initial, this is the initial capacitance. Now you want to increase its capacitance by 10 times. Which are the ways? Increase the capacitance by a factor of 10. Okay, then which of the given option is you can choose? So option A you can supposed to be choose. According to option 1 is equal to what? L. That means capacitance is equal to epsilon naught A. A is equal to what? 30 into 10 power minus 2 into breadth 1 into 10 power minus 2 by distance 1 into 10 power minus 6. 1 into 10 power minus 6. So you get the value is equal to 3 times. So it is not, okay, sufficient to get the required value. Next you can say B, option B. By using option B you can say C is equal to epsilon naught A, means length into breadth. That means what? 3 into 10 power minus 2 into 1 into 10 power minus 2 by D, 30 into 10 power minus 6. Yes, so 3 cancel, then that means you get the value of 10 times. That means option B is correct. Okay, so by using option B you get it is correct, minus 4. Yes, it is not correct here, 30. So it is not correct. So it is also not correct. B, by using B we can doesn't rise it by 10 times of initial value. Okay, now we can take option D. Option B is ho gaya, means C, option C. What is C? C is equal to epsilon naught into length 6 into 10 power minus 2, breadth 5 into 10 power minus 2 by 3 into 10 power minus 6. So 3 to the 2, 5 is 10. That means it may be, yes, it may be correct. You get the value of 10. Result equal to what? 10. That means what? 10 of epsilon naught. Next option D. What is option D? C is equal to epsilon naught into length 1 into 10 power minus 2 into breadth 1 into 10 power minus 2 by 10 into 10 power minus 6. 10 into 10 power minus 6. Okay, so it may also not correct, not get the required value. Then remaining E. Okay, so you get that is correct or not, we can check once again. Okay, option E. What is the value? C is equal to what? Epsilon naught into 5 into 10 power minus 2, breadth is equal to 2 into 10 power minus 2 by 1 micro, 1 into 10 power minus 6. What is the 10? That means 10 cancel, then yes, 10 E, 10 epsilon naught. So by using E also you get. So in these given options C and E are correct. Okay, that's it. Okay, the ninth question. An electron of mass m with an initial velocity v bar equal to v naught I cap, that means along the x axis, okay, enters an electric field E bar equal to minus E naught k cap. Okay, if the initial de Broglie wavelength is lambda naught, the value after time t would be, okay, you know what is given velocity, initial velocity, what is that? V bar is equal to what? V naught into I cap. Okay, so it is enter into an electric field. an electron of mass m with an initial velocity v naught enter into an electric field. So, after it attains, that means enter into an electric field, it possesses some acceleration due to electric force acts on it. Okay. So, after some time its velocity. Okay. Before finding it, we may calculate velocity, wave. Okay. Anyway, after some time, its velocity from v is equal to u plus at equation. Okay. What happened? That implies v bar is equal to initial velocity. What is that? V naught into I cap. Okay, v naught into I cap. Okay, minus v is equal to u plus u into a. Here a is equal to what? From Newton's second law, F by m. F is equal to what? E q by m. Okay, any electron enter into an electric field possesses some acceleration, which is equal to what? E by m. Okay, minus E by m into k cap, into what? K cap. Okay, therefore, velocity, magnitude of velocity after some time is equal to, what is that? V naught square plus minus E by v is equal to u plus a into t, okay, into t whole square, which is equal to v naught square plus e square t square by m square. Okay, this is the velocity after some time. Okay, initial wavelength lambda is equal to what? H naught by h by m into v naught. H E is equal to what? H by m into v naught. Okay, here after some time lambda dash is equal to what? M into v. M into what? V. So, which is equal to what? H by m into v is equal to what? Okay, v naught square plus e square into t square by m square. Okay, therefore, lambda dash by lambda is equal to h by m into when you v naught taken as common, v naught square into what is it? 1 plus e square t square by v naught square. Why? Because v naught taken as common, okay, it is taken outside. So, what is that? Its value. So, which is equal to what? V naught. Okay, right. By lambda is equal to what? Lambda is equal to h by m into v naught. This h by cancel. Therefore, lambda dash is equal to lambda is initial wavelength, lambda by under root 1 plus e square t square by m square into v naught square. Okay, this is the wavelength, okay, of that electron after some time t. Okay, right. Okay, the 10th question. An alternating current is given by I is equal to IA sin omega t plus IB cos omega t. The RMS current will be, this is a direct question. What is the RMS current? Root mean square. Okay, according to definition, RMS is equal to under root, okay, average value of root of average a square root average value of maximum current, that means current flowing in the circuit, that is called square root of average square, that means this. So, here I square E is equal to is the time average. What is that? It is the time average of what is that? I square, current square. Okay, therefore, sin square omega t. What is that? Sin square omega t average value. Okay, which is exactly coincidence cos square omega t equal to what? 1 by 2 in a complete cycle. In a complete cycle, in one complete cycle, what happened? Average current equal to what? Okay, what is that? Average value is equal to what? 1 by 2. Okay, similarly, sin omega t, or sin omega t into cos omega t is also equal to what? 0. The product is 0. This square is equal to what? 1 by 2. Okay. So, mod I square is equal to what? I a square by 2 plus I b square by 2. Okay. Therefore, I RMS is equal to under root I a square plus I b square by 2. So, this is the answer for this question. What is that? This thing. Okay, right. This is the RMS value. Okay, right. Okay, the 11th question: a square loop of sides A is equal to 1 meter is held normally in front of a point charge. To see, this is a point charge Q. Its magnitude is equal to what? 1 coulomb. That means given charge. What is that? 1 coulomb. Okay. This 1 coulomb charge is kept normally in front of a square loop of side 1 meter. Okay. Side A is equal to what? 1 meter. Okay. The flux of the electric field through the shaded region. The flux of the electric field through the shaded region is equal to 5 by P into 1 by epsilon naught Newton meter square per coulomb, where the value of P is. Okay. How to calculate the value of P used by using this given figure? To see here, this is a square, isn't it? Square loop. So, you know one thing, what is that? The electric flux. What is that? The electric flux through a square loop, is equal to 1 by, that means charge Q by epsilon naught times of 1 by 6. So, this is a standard flux through a square loop. What is that? Q by epsilon naught into what? 1 by 6. Okay. Now, this is the given, that means let us given loop, given square loop divided into 8 equal parts. 8 equal parts. How you can say? To see, this is the given square loop, isn't it? Okay, this is a given square loop, okay, which is divided like this way. So, what happened? This is 1, 2, 3, 4, 5, 6, 7 and 8. According to this one, how many parts are becomes shaded? To see this part, that means 1, 2, 3, 4, 5. That means 5 parts are becomes what? Shaded. Here 5 parts are become shaded. So, what is asking? How many flux are emitted from these 5 shaded parts after this square loop is divided into equal parts? This is asking. So, therefore, flux through the shaded region, flux through the shaded region, what is that? 5 by 8 is equal to how much? 5 by 8 into Q by epsilon naught into what? 1 by 6, isn't it? Here, so what is the value? 5 by 48 into Q by epsilon naught, but you know Q is equal to what? 1 coulomb. So, which is equal to 5 by 48 into 1 by epsilon naught. So, compare given thing into this one. In place of P, how much? What is the value is there? Therefore, P is equal to what? 48. So, answer for this question is what? P is equal to what? 48. Okay? Right. Here to see why you get this for P is equal to 48? Because you know this is the charge how much far away from the center of this loop, it is not given. So that I would like to define which is equal to what, a by 2, then only it is correct. Okay. So, in this question some ambiguity is there, that means the question is not completed. Okay. How they are considered we didn't know. Okay. So, keep it in your mind. Okay. Right. Okay, the 12th question. A wire of resistance 9 ohm, what is it? A wire of resistance what, 9 ohm is bent to form an equilateral triangle. Then the equivalent resistance across any two vertices will be dash ohm. Okay, what is given? A wire of, that means total resistance of the wire. Total resistance of given wire equal to what, 9 ohm. Okay, when it is bent like an equilateral triangle, what is it? When it is bent in the form of an equilateral triangle. Okay, therefore resistance of each side, how much? 3 ohm obviously, isn't it? Equilateral triangle, that means the 9 ohm resistor is bent into a form of equilateral triangle. So, each side having, okay, each side wire having what, 3 ohm. But what is asking, then the equivalent resistance across any two vertices, to see when you bend like this way, what happened? Same current is flow along this 3 ohm resistor and this 3 ohm resistor, but different amount of current passing through this 3 ohm. So that these two, that means these two, this 3 ohm, this 3 ohm are in what, series. So, it may be right like this. So, 3 ohm plus 3 ohm, these two are in series, isn't it? These two are in parallel with respect to this. Okay. So, this is B and this is a called C, this is the given Y. So, what is the value of these 3? That implies the equivalent 3 plus 3 is equal to what, 6. Why? Because in two resistors are series, the resultant equal to what, R1 plus R2, 3 plus 3 is equal to what, 6. Now, this is in series parallel with what is the 3 ohm. Okay, that implies net resistance equal to what, 1 by 6 plus 1 by 3, 6 is the LCM, 1 plus 2, what is that, 3 by 6 equal to what, 1 by 2, that 1 by 2. Therefore, R net equal to what, 2 ohm. What is this show? Equivalent resistance equal to what, 2 ohm. This is the equivalent resistance. Okay, right, that's it. Okay, the 13th question, this is the last question. Okay, okay, what is that? A current of 5 ampere exists in a square loop of side 1 by root 2 meter. Then the magnitude of the magnetic field B at the center of the square loop will be P into 10 power minus 6 Tesla, where value of P is. So, what is given? A current of 5 ampere exists in a square loop. Suppose to see this is a square loop, this is a square loop, okay, which carries 5 ampere current. Okay, of side how much? 1 by root 2 meter, 1 by root 2 meter. Then the magnitude of the magnetic field B at the center of the square loop. Suppose this is the center of the square loop. So, where how much magnetic field is there? Okay, you know one thing from Biot-Savart's law. From Biot-Savart's law. Okay, what is that? Magnetic field due to a straight current carrying conductor is equal to mu naught by 4 pi I dl sin theta by r square. To see, this is like a straight conductor. Okay. So, at the center of this square, how much distance from this end? Same distance from this end also. So, the center point is made an angle 45 degrees with respect to this end, similarly 45 degrees with respect to this end. It is supposed to called say alpha, this is supposed to be called what is a beta. Okay. Therefore, when you integrate the magnetic field at a distance, how much distance it is, that means the side is 1 by root 2. So, the center point is how much distance from this side? 1 by root 2 by 2, okay, which is equal to side, that means d. Okay. It may calculate b is equal to mu naught I by 4 pi d into sin alpha plus sin beta. Mu naught I by 4 pi d into sin alpha plus sin beta. Okay. So, you know 4 pi is equal to what? Mu naught is equal to 4 pi into 10 power minus 7 Tesla meter per ampere into I. What is the current value? 5 by 4 pi into d. What is the distance? Side is 1 by root 2, side is half of it, that means 1 by root 2 by 2, that means 1 by 2 root 2, 1 by 2 root 2, okay, into sin 45, alpha is equal to what? 45, beta is also 45. So, sin 45 plus sin 45 degrees. So, what is it? 4 pi is cancel, 10 power minus 7 into 5 by 2 root 2, that means sorry 1 by 2 root 2 into 1 by root 2 plus 1 by root 2. Okay. So, it may be write like this. What is that? 10 power minus 7 into 5 into, when go to the numerator, 2 root 2 into 1 by root 2 plus 1 by root 2, 2 into 1 by root 2, this root 2 is cancelled, then you get 5 to z 10, 10 to z 20 into 10 power minus 7, which is equal to b is equal to what? 2 into 10 power minus 6 Tesla. This is just to one side. Similarly, this side is also carrying same current. So, this is also at a distance of same 1 by root 2 by 2. So, this is also same, contribute some magnetic field at its center. This side is also contribute magnetic field at this center. So, due to four sides of okay square loop, okay, magnetic field at the center, at its center is equal to what? 4 into b, that implies b is equal to what? Center, magnetic field intensity at the center, 4 into 2 into 10 power minus 6 Tesla, that means what? 8 into 10 power minus 6 Tesla. So, in place of p, what is we get? 8. So, it is the answer for this question. Okay, right.